Greetings, and welcome to this episode in the series of videos on working with remote sensing with ArcGIS Pro. This series is brought to you by AmericaView in partnership with Virginia Tech, the Virginia Cooperative Extension, and Virginia View. I'm Cherie Aukland, and I'll be your guide. This video tutorial series builds on ongoing and previous collaborations and contributions provided by the USDA NIFA through the ADVANCE project, the National Science Foundation, through the GeoTED UAS project, the Ohio State University, and the Virginia Space Grant Consortium. This video series is associated with the Remote Sensing with ArcGIS Pro 2nd edition book. We will use Landsat 9 imagery in this series, and we'll also begin with Chapter 10. Links to resources for this video series, including free access to the textbook and to the videos for Chapters 1 through 9, are available in the video description below. As noted in the previous two chapters, image enhancement is processing remotely sensed imagery to adjust brightness values to improve qualities such as color balance, brightness, and contrast between pixels. Image enhancement can improve the image's visual qualities for a specific task. Spectral enhancement is our third topic on image enhancement techniques. Please see your textbook for a detailed overview of spectral enhancement, including what spectral enhancement entails, and techniques for spectral enhancement, such as the most commonly used techniques of spectral ratios, principal components analysis, and tasseled cap. This video demonstrates band ratios and indices in ArcGIS Pro. Examples of band ratios and vegetation indices in ArcGIS Pro are provided in this video, with details of the technique covered in the text. We recommend you read the chapter discussion on this topic before reviewing this video. You can begin with a new blank map project if you like, adding the composite image and individual bands needed, and setting your workspace to the project's geodatabase. Here, I started with the Chapter 18 project, removing all but the 6-band composite image, displayed in 321 natural color, and adding the individual bands 4 and 5 from our Landsat 9 images we downloaded in an earlier chapter. Let's begin with band ratios. There are two methods for creating simple indices for ratios based on using two bands. The first method uses the raster functions in the Imagery tab. The second method uses the Geoprocessing Spatial Analyst math tools. The difference between these is that the first method creates data that can only be used in the current map project, while the second creates new data stored in the geodatabase for later use. We'll discuss both methods. Under the Imagery tab, let's select Raster Functions. The Raster Functions pane lists several tools in the expanded Analysis category. Many of these are also available from the Geoprocessing pane. Scrolling down, any of these additional categories can be expanded to show more processing tools. Let's expand Math, and you can see the individual math tools that are available. ABS, Divide, and Minus, for example. These are used with single-band images. Band Arithmetic is used with multi-band imagery. Let's choose Band Arithmetic. The default method you see here is NDVI. We'll talk about that later. Drop down Method. Here's a list of available ratios. For simple band ratios, scroll up and select User Defined at the top. We'll create a near-infrared divided by red ratio, which enhances the presence of vegetation. For the raster, we'll use the composite image. Under Band Indices, we'll enter the equation near-infrared divided by red, but we need to remember that the band numbers associated with our image assigned by ArcGIS Pro are band 4 for the near-infrared and band 3 for the red. I'll enter B4 divided by B3. And in the General tab, I'll name it RF_NIR divided by red. You can add some details here for the description, including some metadata to provide information on the process. I'll skip that here. Let's create a new layer. In the new image, the brighter tones indicate denser vegetation. The symbology and contents shows the higher value as the lighter color and the lower value as the darker color. Let's confirm that the results showing brighter are denser vegetation. Let's turn on the swipe tool and compare the new image to the natural color composite. The brighter areas represent the forests, and the darker tones represent some fallow agriculture and developed areas. Zooming in to the city of Roanoke, the roads and river appear very dark. No vegetation is present in the dark areas. While the raster functions create a new image that shows as a layer in contents, this image is only available in the current map project. No new data was created or saved in the geodatabase, so be sure to save the map project. To create an image with data that we can use in other projects, we must use some geoprocessing tools. So let's repeat the process. This will require a couple of steps. First, when using the geoprocessing tools, the pixel values for Landsat imagery are treated as integers, whole numbers. So when performing math functions, the results are integers, usually rounded down, resulting in loss of information. Results for band ratios must be real numbers or numbers with decimal points. This means we must first change our image values to floating point or real number values. Let's open the geoprocessing pane. Analysis, Tools, or if you're like me, I leave it open down here, and search for float. We'll use the Float Spatial Analyst tool. This tool uses individual bands, not the composite image, so the tool must be run twice, once for band 5, the near-infrared band, and once for band 4, the red band. If you didn't add these bands to your project at the beginning, you can navigate to them again using this file folder right here. I'm going to run the tool twice, one with band 5, naming it float_B5 NIR, and again with band 4, naming it float_B4 red. You'll have two new layers in contents and the map viewer. The range of values is the same as we see here. Let's look at the B4. So the range of values here is the same as the range of values up here, but the difference is the new images have values that are real numbers. I'm going to go ahead and collapse these. Now let's create the ratio image near infrared divided by red using the Divide Spatial Analyst tool. Let's go back to the geoprocessing window here and we'll search for divide. And we'll choose the Divide Spatial Analyst tool. So our input raster, or constant value 1, is going to be B5 NIR. Remember, it's NIR divided by red. And our second one is B4 red. We're going to name it GP_NIR divided by red. And I put the GP on the front just to remind us that it's the geoprocessing tool that we used. And then we'll run it. Here's the new image in contents. But since we use the original single bands, so if I zoom to the layer, and not the subsetted bands in the composite, it's the full extent of the Landsat scene. You can compare pixel values for this process versus the raster function process to verify they are the same. Let's turn this off, and let's zoom into a pixel, any old pixel here, just as long as we can tell where we are. So we'll choose this sort of dark pixel, and I'm going to turn the swipe tool off real quick. So I have to go to Map and Explore, and I'm going to click this pixel, and note that the value here is 3.608930. And if I turn off this top layer and I go back to the same pixel, it's still 3608930. Now pause this video and generate another ratio image using band 4 divided by band 7. This is red divided by shortwave infrared, or SWIR. This ratio is often used to identify differences in water turbidity. You can use either method outlined before, but if using the geoprocessing tools, don't forget to modify the floating point image for each band. And remember, geoprocessing tools create a new image that can be used in other projects. When you get back, I'll show you how. Cleaning up a couple of things and zooming to the layer. Now for demonstration purposes, I'll use the raster functions band arithmetic. So I'm going to go back here to raster functions because I happen to have it open, and here's band arithmetic under the math category. I want this to be user defined, and I'll choose our composite image, and I'm going to type B3 divided by B6. And under general, I'll give it a name RF, so raster functions, underscore red divided by SWIR. And create a layer. In this new image, you can see that areas of water are very bright. The new river, Smith Mountain Lake, and Carvin's Cove are very prominent, as are other individual water bodies scattered throughout the image. This band ratio also shows water turbidity, so let's zoom into Smith Mountain Lake. While most of the lake is very bright white, dark areas are apparent in the southeast, where the lake drains into the river, as well as in the northwest branch. I'm going to zoom out a little bit so we can see that a little better. So here's the northwest branch. You can see some dark areas, and here's the southeast branch. I'm going to zoom back in, and we'll use the swipe tool to compare to the natural color image. The river runs through a city and some agricultural areas, so it's experiencing runoff, which makes the water more turbid and sediment-filled, displaying brighter pixel values in the natural color image and a bit darker in the ratio image. In the dam here, the areas right above and right below the dam are more turbid because the water is funneled through the dam's turbines, thus flowing more rapidly than the areas farther north and west. Any simple ratio can be accomplished with these methods, and more complex ratios can also be accomplished using these tools, but ArcGIS Pro has some shortcuts for many processes. The Raster Calculator Geoprocessing tool allows calculation in one step. Let's explore these with indices next. Vegetation indices are another form of spectral image transformation. We'll demonstrate 3 of these: near-infrared divided by red, square root of near-infrared divided by red, and NDVI. We've already calculated the near-infrared divided by red with the Landsat 9 band 5 divided by band 4 ratio. Let's look at the square root of near-infrared divided by red next. Since we already have near-infrared divided by red, we only need to run a tool that calculates the square root. So on the Imagery tab, Raster Functions, which by the way we have open on the right side, we're going to run down to Math and select square root. Let's choose one of the 5 divided by 4 ratio images that we created and leave all the other settings default. Let's name it under the General tab and create new layer. Zooming to the layer, we see that the new image is the full extent of the Landsat scene because we use the image created with the geoprocessing tools. And remember, since we used raster functions, the image exists only for this map project, so you should probably save your project right now. You can run the process using the geoprocessing tools if you like. We won't demonstrate it here. Let's look at what this image shows by zooming in on the mountain area around Carvin's Cove. Carvin's Cove is this little area right here. I still have the swipe tool on, but if I use my middle mouse wheel, I can pan around the image and zoom in and zoom out. I'm going to make sure to turn on the near-infrared by red image below this new image so that we can swipe through it. And now swiping through it, it's hard to see, but notice that adding the square root function makes the image slightly brighter and provides a sharper distinction between features. Now that I've demonstrated a method to generate an enhanced image using an index, it is possible to do this using Raster Calculator in just one step, using a bit more complex equation. Let's open the Geoprocessing pane and search for the Raster Calculator. We'll use this Raster Calculator Spatial Analyst tool. So we'll create an equation using the rasters on the left and the tools on the right that basically says float band 5 near infrared divided by float band 4 red. I'm going to type in a left parenthesis, double click float band 5 infrared divided by float B4 red, and well, I forgot the divide in there. Guess I'm going to have to double click it and end my parenthesis. I could also have calculated the float right here too, but since we have the float images already, I just use those. Be sure to name your output raster and run the tool. For the result, there is no difference between the two methods except for the number of steps. Also remember, we now have a new image that's available for other map projects. Pause this video and review the two images to convince yourself they are the same. You can see just by turning on the symbology that the ranges are the same here. All right, let's look at another index, the Normalized Difference Vegetation Index. This is an important and the most commonly used vegetative index. Recall that healthy green leaves have a higher reflectivity in the near-infrared band, while stressed, dry, or diseased vegetation display lower levels of reflectivity. NDVI can be used as an indicator of vegetation stress. It's a more complex calculation. Here's the formula for NDVI: near-infrared minus red divided by near-infrared plus red. Let's go back to the raster calculator. I'm going to clear it out by doing that and reloading it. And we now need to build the equation near-infrared minus red divided by near-infrared plus red. Typical mathematical order of operation applies, so be sure to include parentheses. So we're going to type the parenthesis, double-click the appropriate image to add it, minus band 4, just hovering over it, that's band 4, the red band, end my parenthesis, and let me make this a little bit bigger so you can see that better, divided by, begin a parenthesis, band 5, near-infrared band, plus, see if I can find that plus, band 4, red band, end parentheses. Let's name our output raster and run the tool. Let me collapse this down a little bit. And let's zoom to this layer. Notice that the NDVI result gives pixel ranges from -1 to +1. The closer to +1, the brighter the pixel. Higher pixel values are associated with more vigorous or healthier vegetation. For this image, the brightness values only range from -0.23898 to +0.677991. This is because we don't have any values at the absolute ends of the range. So after going through all that, there is an easier and much simpler way to generate an NDVI image in ArcGIS Pro. As usual, there's a catch. The NDVI shortcut tool generates an image that is only available in the current map project. Let's go to the Imagery tab and Raster Functions. Let's scroll up and find the NDVI tool in the Analysis section. And for this one, the raster is the composite image. We'll choose 3 for the visible band ID and 4 for the infrared band ID. And we'll check the box for scientific output, then create new layer. Notice in this new shortcut tool, there is a different range of values from those generated by the raster calculator. This was generated from the subsetted composite image, and the raster calculator was created with the image from the extent of the scene. Let's zoom this to this layer. Now for discussion, because you see some color here and your color may be different from mine, there is an NDVI colorized option, as you see here. This generates a color map or color ramp to display the output, but it's not as you might expect. Let's try it. So we'll choose our composite. Our visible band is 3. Our infrared band is 4. And create new layer. Now if we look at the symbology for what we just created, we see colorized pixels, but the pixel values and contents are integers, not real numbers. With NDVI, the value of the pixels should range from -1 to +1, not values over 1 like you see here. So if you do need a specific colorized version of NDVI, create the index using the Geoprocessing Tools, and then change the symbology. There are alternatives to creating NDVI images yourself. See the USGS website here. Surface reflectance products, including NDVI, can be ordered as on-demand products. They cannot be directly downloaded. However, the authors believe there is tremendous value in learning to generate image-derived products using spectral enhancement techniques and not solely relying on pre-processed products. When we first introduced raster functions band arithmetic, the default was NDVI. But under Method was a list of many additional indices. Each one of these indices has been vetted within academic research and literature. These should be reviewed for specific applications. For definitions of the additional ratios available under raster functions, see this ArcGIS Pro website. Any spectral band index can be created using ArcGIS Pro with the raster calculator and manually typing the equation, or with several steps using the map algebra tools identified in this video. The next chapter of this book, Change Detection, will require downloading 2 additional Landsat 9 scenes, so be prepared to review and utilize skills acquired in chapters 11, 13, and 15.